get to the 5.1 notes. All right, so first, solving an equation here. Do you guys know how to solve the first equation?
Yeah.
Yeah, you'd add your 3x, right, to both sides, subtract 12. 11x equals 22. Divided by 11, right? X is 2. But you've been doing that for I don't know how many years, but you're pretty good at that. 3. I think it's been more than 3, but maybe not. All right. We are going to do a similar approach, but now with trig equations, okay? So this 3 minus 4 sine squared, you would subtract your 3 first. What do you think I'd do after that? Divide by negative 4, right? Didn't really give you enough room here. So then I've got sine squared of x equals 3/4. How do I get rid of the square? Square root, yeah. So sine of x is going to equal, what do I need since I solved with the square root? Plus or minus. A few of you forgot that when you completed the square. So you get plus or minus √3 over 2. Are we okay to that point? All right, that's not solving for x, though. You're not done. Your directions would include something else like from 0 to 2 pi, meaning I want solutions that are between 0 and 2 pi. So what you need to tell me now is when does sine equal positive or negative √3 over 2?
Pi over 3.
What? So think back to your circle.
Oh, okay.
Yep, that's what we're doing. That's that whole 0 to 2 pi. So where on your circle is sine positive or negative √3 over 2?
Can I just ask a small question? Do you want it like in degrees or radians?
So it depends on what the directions are given in. If it says 0 to 2 pi, radians. If it says 0 to 360, degrees. Yep.
Pi over 3, 4 pi over 3.
Good. All of your over 3s, right? That makes sense? So that's kind of the gist of where we're going with this stuff. We're going to start, though, by thinking about what inverses are. Because, guys, what you're doing there is you actually did the inverse of sine to get that. You don't really write it that way when you solve, but that's technically what you're doing. So let's think back to Algebra 2 stuff now. I'm going to make a little table of values here from this graph. I think you know these. I can have 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. What would the vertical line test tell me?
Linear. Or not linear, function.
Function? Okay, so the vertical line test, it determines f of x is a function. Looking at our f of x, what do you think? Is that a function? Yes, passes the vertical line test. Okay, do you guys remember the horizontal line test? Yes? What does it tell us? Right, so it determines if the inverse of f of x is a function. So looking at our f of x, is the inverse going to be a function? No. How do I, like, what else do I do with my graph to think about the inverse? What else do you guys know about inverses?
Inverse of 90 degrees. Or reflected over the board.
You're reflected over something. Yes. Reflected over the line y equals x. And what does that do to our x and y values? It switches them. So I've got this table here. If I just switch those ordered pairs, that should be values for my inverse. So if I do Okay, just switching x and y, and look at my graph. Did those values show up on this graph? Okay, is that graph a function? No, it's the inverse. The other one didn't pass the horizontal line test. Okay, that's just reminding you about inverses. Okay, keep things easier. All right, let's keep deleting. Don't need that. Okay, so now we're going to get into the inverses of our trig graphs. Okay, so let's look at our first one here. This is
When it says sine of -1, and it says sine to the -1 of x, isn't that just cosecant?
no
1/sine.
different. If it was, and you don't ever write it like all of this, the -1, you just don't see it that way. If you want the reciprocal, like cosecant is the reciprocal, but if you see inverse sine, or a lot of times it's written arc sine, I think because that eliminates that confusion, that means the inverse of sine. It's not the reciprocal, it's the inverse. Okay, and we'll talk more about what that actually means, but let's look at the graph first. So this is just your parent graph of sine, most of it anyway. So if I know the inverse switches the x and y, to graph it, I'm going to switch how I label my x and y axis. Okay? So what is on the x-axis of my original, I'm going to go ahead and put on my y-axis. So pi over 2, pi, 3 pi over 2, 2 pi. And then my x-axis, I'm just going to go 1 and -1. Okay, so let's think about some points on this graph. On sine, I have the point 0, 0. So when I do the inverse, what point does that become? 0, 0. Good. All right, the next point then for sine is pi over 2, 1. So what am I going to graph?
1 over 2.
Then I have pi 0, so I will graph
0 pi.
Thanks. Did you guys get quiet? Do we not see it, or are we just being quiet? Just graphing? Okay, you see it too well. So 3 pi over 2, -1 is going to be -1, 3 pi over 2.
So you just graph sideways.
Kind of. It's actually reflected over the line, y equals x. All right, follow the pattern all the way down into the negatives, and then this. Is what your graph is going to look like. All right, is that a function? No. Okay, so what we're going to do is called restricting the range on this. We're going to pick values like a window that allows this to be a function, but we'll cover every value of the graph. So everything from -1 to 1. But I want it to be a function. Any guesses on what my window might be? Sammy?
-5 over 2 to 5 over 2.
Perfect. So if I look at just that, right? It's a function. Okay. That's all I need, right? Okay, if I go beyond that, it's not going to be a function anymore. Now, this graph continues forever to infinity to -infinity. There are obviously other little sections of the graph that would look exactly like this, but this is the section that we choose, okay? So you always want it to be kind of around the origin. So we only look at this little part from negative pi over 2 to pi. Like, that's it. Sorry, to pi over 2. I don't think I said that right. Okay? You with me so far? All right, I want you to try to graph inverse cosine and pick your window. What do you think? Give you a minute to work on that. All right, guys, compare with someone around you. How are you doing? Okay, so does your graph look like that? Okay, what window did you pick?
0 to pi.
Excellent. Alright, you want 0 to pi. Okay? Yeah.
What's your name?
So you're right, it's the same values. There are actually certain textbooks that use negative pi to 0, but what we're going to do with everything moving forward, pick 0 to pi, okay? So you're not wrong, but this is what you need to use for how to treat here, okay? All right, try tangent. Clearly going to be more fun. So what do you think happens to those vertical asymptotes?
Horizontal
They
asymptotes.
do become horizontal asymptotes.
The y-axis in terms of pi over 2 or pi over 4.
I would do go pi over 4, pi over 2, but then that's all you need to do. Do you guys see how the asymptotes kind of give you your window this time? When you're ready, look up here to check your graph. Does kind of look like a cube. Do you see this time how it's not just rotating your graph 90 degrees? Like if I took this, twisted it, it's not going to look like this. You see it now? Okay. Alright guys, and when I write this, I've got negative pi over 2 to pi over 2. These are asymptotes. I'm putting brackets around it because when we answer questions about inverse tangent, we can use those values. But technically, if I asked you the range of this, they wouldn't be included. Okay, so for right now, we're going to use it with brackets just because those are going to be answers that are available to us. Okay? All right, I'm not going to make you graph the other three. I think you could. Okay, just look at the original. To switch your x and y. The other three would all have horizontal asymptotes happening in them as well. At the bottom of the page here, you'll see what the window ends up being for all of them. So we did sine, cosine, tangent, and then you can see cotangent, secant, and cosecant. Did you guys notice how it's sine, tangent, and cosecant that all have very similar windows? And then cosine, cotangent, and secant. Does it make sense to you that secant would go with cosine and cosecant would match with sine? Hopefully. Yes. All right, questions so far, guys?
What is cosecant's range of minus?
So it's saying that's where the asymptote is. So again, if we're actually writing the range, you would eliminate 0. But if we're talking about answers available to us, you would include 0. Okay, so yeah, it's just where the asymptote is. I don't know why they did it on that, but yet with tangent and cotangent, still put hard brackets. It's very weird. So, all right, okay. Let's keep going. I added a few examples here, and I changed some, so let me erase just a little bit here. And you can't read that, so let me... Okay, so back at the top, we have these two little grids. This is sort of taking us from the graph we just did back to our unit circle. Okay, so inverse sine, inverse tangent, sorry guys, and inverse cosecant. What was the window we used for all three of those? Negative pi over 2 to pi over 2. So if you are thinking on your unit circle, are we okay with negative pi over 2 is down here? And positive pi over 2 is up here. So if I'm talking about the values in between there, it would be this side of the circle. Okay. I'm going to label the things that we know in this part of the circle. So first quadrant, we know pi over 6, pi over 4, pi over 3. And this is 0. But what do you think about the fourth quadrant? Am I going to call that 11 pi over 6? What'd you say?
Negative pi over 6.
Yeah, negative pi over 6. And then negative pi over 4 and negative pi over 3. So you guys are used to, like, on your time trig quizzes, I'll ask you, like, the sine of pi over 4, and you'll tell me root 2 over 2. Hopefully you tell me root 2 over 2, okay? What we're doing with inverses is we're switching what I'm asking you for, okay? So I was asking you for, like, the ratio that's out here in the ordered pair, right? When you do an inverse, I'm asking you for the angle. So like the way that would be written is inverse sine root 2 over 2 equals, and you'd have to tell me the angle. You'd have to tell me the pi over 4.
What do we have to say in terms of negative pi over 6?
So that's, yeah, so if I had, and I'm going to erase this here in a second. Let's say I asked you inverse sine of negative root 2 over 2. Okay? You are not thinking on the entire circle right now. You are only allowed to think here. These are the only options for answers that you have when you're doing this. So what do you think? Where would sine equal negative root 2 out of 2? These are, yes. Okay. So you guys see how you get an angle? The answer is an angle. Okay. It's just reversed. It still goes back to you knowing your unit circle values really, really well. But if you told me inverse sine negative root 2 over 2 and you told me 7 pi over 4, you would not get credit for that. Okay? It has to be within this little window that we graphed. Because if you think back to your graph, you don't have to write this on there.
Why do we keep this function?
Because we have to. We're talking about the functions that are inverses. So we only want to look at a small window of it. Otherwise, you'd be talking about an infinite number of answers, too. Yeah. So, like, if you told me 7 pi over 4, you guys see how that would be, like, up here in this part of the graph? That's not in this green window, right? Okay, so that's why that's not okay. I only want answers in this little section. Okay. All right, so let's look at our other circle that we have here. So inverse cosine, inverse secant, and inverse cotangent. What was our window that we looked at for those? 0 to pi. Okay, so we only went from 0 to pi. So my labels are just normal, okay? Because I'm just going from the first quadrant into the second quadrant, and that's it. So I'm looking at pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, and 5 pi over 6. So if I ask you one of these inverse questions and it's something from your unit circle, this is it. These are the only answers you can give me. Okay? Don't tell me 5 pi over 3. That's not an option. All right? So let's practice a few of these. So squeeze in these 3 extra examples that I wrote down and go ahead and change number 6 for me. I'll give you a minute here to write those down. So just write them down. We'll go through them together. I know you can't listen while you're writing. Or at least not well. All right, so let's look at that first one together. Inverse sine 1/2. Okay, it's inverse sine, so right away I know this is it. These are my only choices. Okay? It's positive, so is that first or fourth quadrant? First, so this is it. Here are your choices. Where does sine equal 1/2? Okay. That's it. second one, inverse cosine negative root 2 over 2. Inverse cosine, so this is the part of the circle I'm looking at. Negative. So it's got to be over here. So where does cosine equal negative root 2 over 2 out of the second quadrant? So 3 pi over 4? Oh, I wasn't sure if you said the 3. All right. Inverse tangent, negative root 3 over 3. All right, tangent, over there, negative, fourth quadrant, root 3 over 3, negative pi over 6, yes. Okay, let me stop there for a second. You're getting it? Like, do you see what's happening? How it's the same idea as you were doing before, just you're going in reverse. You have a small window. Yeah.
5 pi over 6 is negative.
So, no. Okay. 5 pi over 6 is over here in the second quadrant.
Okay.
Yes, tangent is negative there. But inverse tangent, you are only allowed to pick from those two. Okay? Yeah, so you definitely have to know which one goes with which window that we're looking at. And again, that all comes from the graph. Okay? So yes, it's just take your time with these. There's nothing hard. There's not a ton of work you have to show, anything like that. It's just you got to pay attention to the details. Don't screw up your signs. You know, pay attention to what quadrant you're in. All right, so the rest of the practice here, we have multiple things happening. So we've got the cosine of the inverse cosine of negative root 3 over 2. It is. When you have cosine of an inverse cosine, it's just going to be whatever, like they undo each other, okay? You can think through it too, that's fine. Inverse cosine negative root 3 over 2, do you guys see how that's 5 pi over 6? So then this is asking you the cosine of 5 pi over 6, which is negative root 3 over 2, okay? All right, remember arc sine is the same as inverse sine. So for number 2, arc sine of 1/2, what is that going to be? Pi over 6, good. And what is the cosine of pi over 6? 3 over 2, okay? All right, tangent of arc sine of 0. So where does sine equal 0? 0, okay. And what is the tangent of 0? 0, okay, good. Okay so far? All right. 4, 5, and 6 look totally different, right? All right, is 3/5 on our circle somewhere? No. You have to draw a triangle. That like never goes away, guys. Okay.
How do we know?
Yeah, I'll show you. Okay, so we start with arc cosine of 3/5. Guys, the entire purpose of that is to give us an angle so that we can then take the sine of that angle. So it's cosine. My only choice is first or second quadrant to draw it in, right? Okay, with any of these, should you ever draw them in the third quadrant? No, the poor third quadrant is neglected. Don't ever use it, okay? All right, cosine was positive, so what do you think, first or second? First. If you are still not drawing your triangles correctly, please start. All right, the theta, remember, is right there by the origin. Cosine is 3 over 5. That means adjacent is 3, hypotenuse is 5. What is the other side of my triangle? 4. Okay. That's the only reason we need this information for, is to draw our triangle. So now, what is the sine of that angle?
4 over 4.
And you're done. All right, for 5, do we need to draw the triangle, or can you see it? You need it? Okay. So first or second quadrant, because again, it's inverse cosine. First. All right, so adjacent is 3, hypotenuse is 4. Okay, we don't actually need the other side of the triangle, but does everyone understand that the other side of that triangle cannot be 5? Okay, that's actually part of what you guys struggled with on your test, was where you had to find the missing sides of those triangles. Remember, like with the A's and the B's? There were some interesting things happening on there, okay? Which made the rest of that section kind of tough for you. So I don't actually need the other side, because if I want secant, that's just hypotenuse over adjacent. Right? What? 4/3, yeah. Okay?
What's the difference with having the cosine of -1 there, as opposed to just a normal cosine?
Well, you can't take the cosine of 3/4, because 3/4 is the adjacent over hypotenuse. You can only take the cosine of angles. Whereas the inverse cosine equals an angle. You've switched these two pieces, okay? All right, look at 6. So we start with inverse cosecant of -13/12. Okay, which quadrant am I drawing my triangle in? 4th, good. Okay, is the 13 the part that's negative? No, that's your hypotenuse. It's a -12. You're going down, okay? What is the other side? 5. So what is the cosine of this angle? 5/13, yes. Okay. We get it's just a process. There's not too much that you have to think about too difficult here. All right, so just make sure you recognize if you're doing inverse sine of a ratio there, right? That's opposite over hypotenuse. You get an angle as your answer. So this is what, pi/3. That is different. If I took the sine of pi/3, I would get 3/2. Okay? So inverse, you're flipping those things around. It's like your x and your y. Okay. We're going to switch a little bit here. So we're going to jump down to this practice. So we're going to solve some simple trig equations. So what I want you to do is we're only going to solve between 0 and 2 pi. That should be in your directions, and it's not. Okay, so look at these equations. Do you see inverses or arcs anywhere in them? No. So should I be thinking about those restricted parts of the circle? No, I should be thinking about the entire circle, 0 to 2 pi. Okay? So the first one is asking you, when does sine equal 1/2 all the way around the circle? Where does it equal +1/2? Yep. And that's it. Are we okay with why it's not like the 3rd and 4th quadrant? We see it? Okay. All right, then number 8, again, all the way around the circle. Where does cosine equal -√2/2? And 5 pi/4. Yes, that's what we're going to do. If you guys didn't believe me before, do you believe me now that you need to know your circle? That's okay. Okay, number 9. Yes, factor out a sign on this. You cannot move a sign to the other side and divide by sign and cancel things out. You would lose solutions if you do that. Okay, that seems to come up a lot in this unit. So don't write this down. This is what you cannot do.
Will that find you one solution?
It'll find you one of them, but it won't find you all of them.
There's some problems where you're trying to like factor out a lot of things.
Might help you a little. But if you divide by a variable, you're in trouble, okay? Can't do it. So what you can do is factor out that sine of x. And then what do I do with my two factors? Yeah, so I want to know, when does sine equal 0? And when does sine equal -1? So once around the circle, when does it equal 0?
0.
Mhm. 0 and pi. Now, it also equals 0 at 2 pi, but is 2 pi included? Nope, 2 pi is not included. The way I wrote that, you would not include 2 pi. And then where does sine equal -1? 3 pi over 2, yes. Today we're just doing like very basic solving some of these trig equations. The sections 2 and 3 in this unit is, we'll get into more complicated ones where you're going to have to use some of your identities, your formulas. I'll change it to all solutions instead of just around the circle once. We may do some in degrees where you're going to use your calculator for it. Okay, so that's what you get to look forward to after grade. All right, one more. So once around the circle, where does tangent equal √3 over 3? Yes, and? I heard mumbling, 7 pi over 6. Yes, okay. Okay. Questions? All right, that's the end of notes, guys. Okay. So let's turn and look at your homework. So a couple things I want to tell you. If you look at the first page there, section 1 you're going to do with no calculator. That's completely fine. I do want you to cross out 6 and 7 on that first section. They're written in a way that doesn't make sense. Skip. Okay. Section 2, it says use your calculator to evaluate. So this is really just, can you push the keys on your calculator? It says to be in radians, so that means your mode has to be radians. You will get decimals as answers, that's fine. There's not a pi in your answer, it's just the decimal is the answer. Okay. So if you look on your calculator, like second sign is inverse sine. Yep. I'm going to have you skip section 3. So this is just graphing those again. It's not like your graphing unit where you're going to have to graph these and shift them and stretch them. None of that stuff is happening. It's just, the graphs are just to make you aware of why we restrict the windows. Okay? Then there is a third page of it, so I do want you to do all of this page. If you look at like questions 5, 7, 9, and 11, do you guys see how those are just basic algebra equations? The process used to solve those is very similar to the process you'll use to solve the trig equations. It's just kind of to help you. All right. There is extra practice. I am not assigning that. That's something that as we get closer to the test, I would encourage you to do as additional review, but that's not anything I'm going to grade right now. Okay? All right.